Nothing fancy, but all I'm... Nothing fancy here. Oh, you can't see. It works, trust me. You're like, are you sure? What is this? You guys can't see that, huh? Oh, what happened? It just, there's nothing that made it happen, right? It just happened?
Yeah, it just happened.
It wasn't even a bang or a kick, huh? There's no causal relation between my banging and the... Okay, anyhow. Is it even recording anymore? I'm so confused.
No, it's not.
Oh, it is though, but where'd the green thing go? But look.
Oh no, it's in the corner. It's like...
Oh, yeah. Alright. Okay, guys. Ah! I can't handle it. Okay, so. I'm not gonna... Well, I wanted to zoom in, but usually there's like a toolbar. Oh, that's what this is. Oh, here. Oh, here. Okay, here we go. Okay, because you guys don't need to know about my weekend. Okay, so. Alright, so. This weekend, I'm going to... No, forget what I'm going to do this weekend. Okay, next week is your last week of school before finals. And then after that, we're going to have finals. Since you're third period, your finals for my exam for my class is going to be on the 17th. I'm still going to give you guys one more reading exam. Who here is not doing reading counts and needs to do an independent reading exam? Okay, so it's not gonna be too long. I'm gonna give you guys some kind of article. I'm probably gonna give that test to you guys on the 19th, on that last day of school. So I'll probably give you the article like sometime the week of finals, and then we'll do it then. Okay? And it's not like the world. It's not like a novel or anything, so it should be manageable. The packet, something like that. It might be even shorter. Okay?
There's no finals on the 19th?
Finals, no. So the finals week is 16th, 17th, and 18th, and those are all minimum days. Okay? All right. Now, this week we'll probably do some finals review on the 15th and the 12th. That means we could take the unit test on the 11th for chapter 4. Okay? So we're almost done with we're not done with, it's like the first half of the unit 4 test. We'll have to finish the rest of the chapter next semester. So, Aved, we have covered extreme values, absolute value, local extremes, mean value theorem, Rolle's theorem, increasing and decreasing behavior. Now we're graphing and analyzing using graphs. And then we're going to do one more thing, applications through modeling and optimization. Okay, there's two more assignments, and then next semester we'll do linearization, Newton's method, and related rates. Okay?
Newton's method?
Yes, Newton's method next semester. Okay, so you have 2 more assignments left. Well, 3, because over the weekend, what am I collecting or checking on Monday? This one. 4-3C is due on Monday, and then we'll make this due on Tuesday, and then due on Wednesday. We can have our test on Thursday. Okay? Or if need be, we could do the test on Friday, but start reviewing for the final on Thursday. Okay? Does that sound good? Everybody aware? So I'm checking the homeworks every day. They're due the next day. Okay? Do not bring it late. Bring it on time. It will be counted late if you don't bring it on that next day. Chapter 3, all of your work should already have been done, like since a month ago. I'm just collecting it to put it into the grade book today. If your chapter 3 after today is missing, then your test will become invalidated. Okay? All right. Hope that's clear. Questions? Okay, the other thing I want to remind you is that if you want to accept the curved score and not your original score, for example, this person, if they want a 78% on their Unit 3 test instead of their Unit 4, if you want 78% instead of the 44%, you have till next Friday to complete the following. Most of you guys have been coming in to do your test corrections. only two or three of you guys are actually done with that. You need to complete your test corrections during tutoring and then have me sit with you and review them, go over them.
Miss, you don't have time.
I know.
Yeah.
Sorry.
What is?
Hey, they came in at lunch yesterday. I reviewed it with them.
But it should
Yeah,
be,
I'm here at lunch.
should be Wednesdays for us.
I know, but right now they're all failing. So are some of you. Okay.
I mean, too.
But
Are we not
okay.
all failing?
Not all. Okay. So you need to show me proficiency by completing this packet. I'm going to. I was gonna put it on Schoology, but I guess I could make copies during lunch and have it ready. Okay. And then so come to me by the end of lunch. And this is straight up from the Barron's book. Except, by the way, you guys should be purchasing the Barron's AP Calculus Barron's book. We're not gonna use it until like April or no
What version?
March, but get it now. Why not? There's like nice little notes in there, and practice tests you can take. The version, I believe it's version 3rd edition. AP Calculus 3rd edition Barron's. It looks like this.
Wait, the AP calculus test isn't changing, right?
No. Oh, it's 12th edition. My bad. 12th edition. Okay, AP Calculus 12th edition. The fact that you're already asking those questions concerns me, Robert.
What did he ask?
Well, I just don't want to waste money.
You don't pay for it. The school pays for it. Oh, I see. Okay, but if you're not planning to take the AP test, I'm not sure why you're in this class.
It's the only class on.
Okay.
That's kind of true. Why don't we have a regular calculus?
'Cause not
There's
much
no such
difference.
thing as a regular calculus. Calculus is a college level class. You see? So
you
might as
make
well
it
get
harder?
college credit for it. There's no way to make calculus easier, you know? It's an honors level, like nobody that's not in AP level would take calculus, you see what I'm saying?
What's the difference between honors pre-calculus? How can you make that easier?
Oh. Well, there's more topics that we cover in honors. Supposedly. Supposed to. Okay, 12th edition AP Calculus. Alright. And then the third thing you need to do is take an oral exam. So next week, I will sit down with you. I will randomly pick a differentiation problem. It won't be an easy one. Okay, and so
Only
be
one?
ready. 1 or 2. Okay?
What do we fail?
Then you have to redo it.
Oh, we just okay.
I guess. Or, no, I don't like that. That's too easy. Then you don't get your credit.
Oh,
So pass the oral exam. The pressure's on. Okay. You like that? I think Sky likes that.
Can we at least find a middle percentage, because we did two.
Oh, we'll see. Well, don't worry about it. Just plan on passing, okay? All right. So we did this yesterday. Let's continue. Oh, but you guys wanted to do one from the quiz. Okay. Well, you know what? This one from the quiz is from this packet. So we'll get there. Okay? Let's see if you guys remember.
Oh, it's that one down there.
Uh-huh.
Can you do it?
Yeah, we'll get there, but let's do one step at a time. Okay, so I feel like we should do this in a more methodical way, and every year I've just kind of like winged it. But let's try to think of a more methodical way to do this. Uh-huh. Hold on. Oh, here we go. See, banging it does help. Okay, all right, so now we have f prime, okay? So remember we discussed yesterday that what are we looking for? We want to see if f prime it goes from positive to negative, there's a max or min there. If f prime goes from increasing to decreasing or decreasing to increasing, there's an inflection point there. And f prime tells us if f is what? Who's got the chart in front of them? Let's just make a chart. Okay, yes. So what do I know about f? If
Drop something.
me?
No, him.
There you go.
You sure?
Okay, did I put f on the bottom or on the top?
on top.
Okay. All right, so if f prime is positive, what is f doing? No, it's increasing. If f prime is negative, what is f doing?
Decreasing.
Decreasing. Okay? If f double prime, okay, but we don't know double prime. We only know f. But if f is increasing, then f is, okay, so let's actually take it one step at a time. Do y'all agree with me that, is this recording?
You give it to us like in a different way.
I did?
Yeah, like you said, like this. Yeah, you give us concave up and concave down.
We're not there yet.
No, but F is.
Because the reason I'm focusing on this line is because that's the graph that we're given in these problems, right?
Wait, but at the beginning, is it a negative?
That doesn't matter. Now I'm just making a chart right now. See what I'm saying?
I thought we were supposed to follow 3 steps. Like you see where it's negative and then where it's positive.
Yeah. Right now I'm just kind of reviewing before we start the problem. So this is just a sign chart that you can always make, right? So if f prime is positive, we always know that if a function's derivative is positive, that means a function is increasing. Do you guys remember in 4.2 when we talked, 4.3 when we first talked about that?
Yeah.
And you guys believe me, right? That if f prime is negative, then f is decreasing? Okay, well if f prime, because look, on this chart, we can see where a graph when f prime is positive or negative. We also can see by looking if it's increasing or decreasing. You see the difference between saying that f prime is positive and f prime is increasing? Because f prime could be positive and increasing or decreasing, right? In a certain interval. So in this interval, if f prime is increasing, well, let's think about this. If a function is increasing, what does that mean about its derivative?
It's positive.
It's positive. Just like this relationship, this mother-daughter relationship can happen between mom and grandma too, you know? You see? And if f prime or any function is decreasing, then its derivative must be negative. But we know that if f double prime is positive, then f is concave up. And if f double prime is negative, then f
Concave down.
is concave down. Right? Okay. All right? Okay. So now based on that information, let's go look at the graph. Do I need to zoom in a little bit, or are you okay?
We're good.
You're good? Okay. So let's take, you know what, I'm going to use my pink here, okay, to talk about, no, let's not do that. Okay, so let's talk about positive and negative using the red, okay? What's happening to the graph? Let's just look at the signs. F prime, the sign is what here? Negative, and then here? Positive, 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 positive. And then what happens? F prime is negative, 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 and then? Positive, positive. Okay? What does that say about F?
It's increasing.
F should be increase.
No, decreasing.
Oh, sorry, thank you. Decreasing, and then? Increasing from -4 till 1. -1. And then between -1 and 4, what is F doing? Decreasing. And then it increases again after 4. Positive 4. Yeah? All right. Now I'm going to use my black pen. What do we know about F prime in terms of increasing and decreasing?
When there's a change, isn't there like a maximum, right?
A change on who?
So there's an inflection.
On the prime?
Oh, okay, so let's revisit that. Okay, whenever there was a change in f prime sign, where is the first change in f prime sign? At -4. Where else is there a change? -1. Where else?
And 4.
What happens at these points?
The concavity changes.
What? Wait, what's changed? F prime sign changed.
Oh yeah.
If f prime sign changes, that means f went from increasing to decreasing or decreasing to increasing. So what does that mean? There's a critical point. Not only so, we could take it even further and say that there is a max or a min. By what?
By the
Mean value.
Mm,
Extreme value.
yes, Guy. First derivative test. What does the first derivative test tell us?
where the
Where the first
where the
derivative
local
is
max
plus-
and mins are.
Yes, how can we, so basically we know there's a local max or min. How can we,
First derivative equals 0 does not exist.
that's a critical
Sign
point.
changes.
Thank you, Sky. Okay, so when the how do we know if there's a local max or min by the first derivative test?
If it's a max,
The first derivative, sorry, how do we know there's a local max? How do we know there's going to be a max here?
positive.
When it goes from positive.
What's it?
The F prime.
F prime changes from positive to negative. How do we know if there's going to be a local min? F prime changes from negative to positive. So so what's happening here? F prime changes from negative to positive. That means, is that going to be a min or a max? So this is going to be a min for who?
For F.
For F. Thank you. So that's a CP. Not only is it a CP, it's a min. Okay? What about right here? F prime changes from positive to negative. So it's definitely a CP. What kind of CP though?
Max at F.
If we go from positive to negative, it's going to be a max. Does everybody see where I'm getting this information? Daisy, are you okay? You're still processing it? Okay. So let's think about it this way. If f prime is positive, if a function's derivative is positive, the derivative is a slope, right? The slope of the tangents. The slopes of the tangents have a positive slope. That means the graph is looking like this. So it's actually increasing, right? And then, if my first derivative is negative, that means that my tangents are going this way at this slope. So my graph is decreasing. If I go from increasing to decreasing, oh, it's too zoomed in. Increasing to decreasing, what's happening? There's a max there. No, that's not concavity, there's a max. Okay? So the slope goes from positive to negative, so there's a max. Okay? If my slope f prime goes from negative to positive, there's a min. Min on f, right? Okay. So right here there should be a min. Right here there should be a max, and right here there should be a min again. All right. So we're almost ready. Do you guys kind of have an idea of what this graph is going to look like? It's going to go down, up, right? But what do we not know yet? Is there more than one way to go down and up?
Yeah.
If you could go down linearly, or you could scoop it up and go down, or scoop it down, right? Or they could kind of be concave up or concave down. So how do we know about concavity?
F double prime.
We have to look at f double prime. What about f? Oh well, we don't know f double prime. We only know f prime here.
But
We can look at f single prime's what? If it's doing what? Increasing or decreasing. Okay, so let's look at f prime from that perspective. What's happening in this interval? This graph is doing what? It's increasing.
I thought we're talking about the slope of that.
Right, the slope of this is positive, and so this graph is increasing, right? We're not talking about concavity. We're talking about f prime. So these are the four things we could look at, because this is a graph of f prime, right? We can see if f prime is positive or negative, and we can also determine if f prime is going up or going down. So f prime right here in this interval, what's happening to f prime? It's going up. Until where? Until negative 3. So in this whole interval, f prime is increasing, right? And then, I wish I had a different color. Okay. From negative 3 till where is it decreasing?
So -1.
All the way to
No, all the way to
here? To 0. To here?
No, to like 1.
Yeah, because then it's like.
Does it stop decreasing here? Doesn't it keep going down all the way to here?
Yeah.
Okay, so f prime is decreasing. Okay? All right. Now let's go here. From 1 until where is f prime increasing again?
All the way.
All the way till the end. This whole area it's increasing. Yeah? Okay. So, what does f prime's increasing and decreasing tell us about f?
It's gonna concave up. Now we're looking at concavity.
Net tells us, thank you, f's concavity. So in this whole region from negative 5 all the way to negative 3, what's happening to f? It's concave up, thank you. From negative 3 all the way to what now? to 1, we are concave. Down. From 1 to infinity, or at least to 5, we are concave. Up. Now we have enough information to make a possible sketch. Okay? You have this paper out, Mario? Okay, hold on. Let's make a sketch. Doesn't matter where we start our sketch. No, so we can start wherever we want. Let's just start right here. We have to go down from -5 to 4 with what kind of concavity? Up. So I can't go like this, okay? I have to scoop this way. Okay? And there's going to be a min there. Now, we're increasing from -4 all the way to where? To 0. Wait. No, we're increasing to -1. That's right. Remember, look, the sign of f prime was positive only to -1. So we're increasing in this interval, right? On this interval, we're increasing, but with what concavity? Oh, yeah, you're right. To -3, it has a what concavity? Positive, so it's going to scoop up, right? But from -3 to -1, we are still increasing, but with what kind of concavity? Downward concavity. So what is this called right here?
Point of inflection.
Thank you, point of inflection. We're going to continue to increase, but with a different inflection, with a different concavity. Do you see that? We're still increasing. Okay? Now that we've reached -1, where our max is, we can start to decrease all the way to where? To 4. We're going to decrease this entire time with the same concavity the entire time? No. Where does the concavity change? At 1. So from here, we're going to go downward concavity, continue with a downward concavity, and then what? We're still decreasing, right? But what changes? The concavity. So this must be another point of inflection. So we're still decreasing, but with an upward concavity. You see that? Ooh, that almost looks like I'm increasing, so I gotta be careful. Okay, like this. Now what? From here to here, what changes from the 4 to 5? The direction. Now I'm gonna do what? I'm increasing, but what's my concavity? Still down. Still up. So, which makes sense, and this is a min. Okay, well it could be a min still without, yeah. Okay, do you see this graph?
Yeah.
Does that make sense to you? Do you see how we had to layer it so many times? We had to look at so many levels. And not only, because look, the places where the sign changes is different from where the concavity changes. So you almost have to, I feel like patty paper would be really helpful for this. Tracing paper. So when you're doing your homework, don't expect this to be, really easy. Expect to take a lot of time to figure out how to graph this. Okay? Yes, I'll have tutoring during lunch. You can have a pass. Give me like a 5-minute break. You guys go take a break, and I'll take a break.
Can I get a pass now?
Yes.